In this video, we're going to talk about something called interpolation. So if we look at our current game, and if we run this here, you're going to notice once we get onto the moving platform, that our game gets really jittery and we can't move. So if we're trying to move, you see the player's jittering around a little bit, and then when I jump off, it goes back to normal. Now this is a bit more of an advanced topic, but because we're running into this, we're going to do an easy fix to resolve it, but I want to explain a bit what's happening here. So currently when we move our player, we're using physics instead of the player's velocity. But once we hop on this moving platform, if we go into our scripts, you can see for our moving platform, we're moving it just by changing the position. So this doesn't affect the Unity physics engine at all. So essentially what's happening is the Unity physics engine doesn't know what to do with the player during this because we make it a child of this. So we're telling the player to move to a position every time the platform moves. But in physics, that doesn't make sense. That's like, say, having a skateboard rolling down the street and then you're forcibly telling it to go to an exact spot every frame. So Unity just doesn't really know how to make this work. As I said, this is a more advanced topic, and this is something as you get better at games, you have to plan for this. You don't want to move the physics system like this. But for learning, it's kind of okay to break the rules here, and you're going to learn from it. So let's talk about interpolation here for a second. So if we look at the Unity scripting reference and the documentation, so it says interpolation provides a way to manage the appearance of jitter in the movement of your rigid body. So basically what it's doing is between every physics frame in the game, it's trying to automatically move the player or the object that has the rigid body to where it thinks it should be to make it smooth. So it's kind of guessing in between each physics frame. When I'm talking about physics frames, those are separate from the regular frame in our game. Those frames just display information on the screen and run all of our code. The physics system has its own set of frames. So they run at a standard set rate. By default, it's, I believe, 0.02 seconds. But they always run at the same amount. So it's not like our normal frames where sometimes one takes longer than the other. The physics system is always the same. So what this interpolation is doing is between those physics frames, it's assuming the best solution of where to move that object to make it look smooth. Now, in the case that we're moving our object manually instead of using physics like this, that's where the system's kind of going haywire and it doesn't know what to do. So in this case here, we have three options. By default, it's going to use interpolate, which it basically tries to guess where it should be. Then there's the option of no interpolation at all, so it's just going to ignore it. And then there's one called extrapolate, where it's just another way of predicting where the position's going to be. So if we read this information here, for the main characters or vehicles, it's usually recommended to use interpolation, which is correct. Normally we would, but because we're manually moving some of them, we kind of fall in the gray area here. So it says for any other rigid bodies, it's recommended not to use interpolation. So let's try that. Let's go select our player prefab. Let's go look at interpolate and let's set it to none. So now if I run our game, let's see what happens here. Okay, so far everything seems the same. Now let's go jump on our platform. And now we can move freely and it's nice and smooth. And then I can jump off and it's still all normal. Okay, so if you don't fully understand that, that's fine. Don't worry about this part too much here. This is just a way we have to make it work for our game. This is something that you're going to learn bits and pieces of this more as you progress. But at this part of the course, you don't fully need to understand this. You may want to come back and look at this video later after the course and use it as a reference. And it's going to make a bit more sense at that point. Now, while I'm in here, what I want to do quick before we move on is our game manager prefab. If we look at this here, we have our main camera separate from it. So I'm going to actually add this main camera to it. So I'm going to select main camera. Now I'm just going to drag it into the game manager prefab, select the game manager, and I'm going to apply these overrides. So now we have our main camera as part of this. Let's save that, and now let's go check our other scene. It's level 1. Now I need to delete the original main camera here because I now have it in the game manager. This should work fine when I run it. Okay, and everything's working here, but you can see my confiner and where I have everything set up on the screen is a bit off because I didn't set it for this level. So I'm just going to do that quick here before we move on. Now the one thing to note while doing this is each level, when you set this confiner, you need to make sure you don't apply that back to the prefab or it's going to change the confiner for all of your other levels. So if I just zoom out a bit here, I'm going to edit this collider a bit. So over here, I want to raise it a bit because we're going to go up on this moving platform. And then the bottom, I'm going to raise a little bit here because I don't want it to go under the water. Just going to raise this side here a bit. Okay, so that should be good for this one. So I'm just going to test this out. Okay, so now we see our water. We can't go below, even if I fall off. Notice it won't go below. And let's make sure our camera goes up when we move up on our platform. Now you will notice with this, when we're on the moving platform, there is still some jitter there. That's always going to happen with this method, but it's going to be pretty minimal compared to everything else. As I mentioned earlier in this video, this isn't the ideal solution, but at this point of the course, I don't want to dive too much into how we can make our platforms move with physics yet. We're going to come back to that later and refactor the code on the platforms so it works a lot smoother. So don't think this is the permanent fix. This is just something so we can proceed with the course and it's not too complex that you're going to get confused by it. So now that we have that set up, we're ready to move on.